I hope you are seeing the slides. Am I right? Is it visible for you?
Yes, yes.
Yes.
Okay.
It's clear.
Okay, brothers. Good morning. Inshallah, today we are going to discuss chapter number 2. We already finished our chapter 1 in the last week. Have you go through all the problems? Have you worked out that
Yeah,
5
most of
problems?
them.
But yes, please, brother, don't waste your time. Every week we are going to deal with a chapter, and after a chapter we are going to discuss 5 problems. During the weekend, take a practice. In the exams, we will give the question based on the problems what we solved on the class. Okay, so based on that problem only we will give the question. Similar type. Sometimes the same question with the different values. Sometimes the problems may be exactly similar like that. Apart from that, we never go out of the syllabus. Understand? So please take a
Yes.
practice after a week. So every week, when we just covered the chapter, go through the chapter. You already have the slides with you. Take a paper, solve the question by yourself. Understand? Okay, before we go to the lecture, I would like to tell you regarding your lab classes. I hope you all see the messages in your blackboard regarding this week lab. We converted this week lab into online. Hopefully your concerned lab teacher will teach you about how to draw the graph, something related to your practical only. Understand? So the teacher will give some information about your practical classes. That means lab classes, some introduction. So maybe inshallah by week 3rd onwards, it may be on our campus. Okay. So you should be very, very careful. When you just come to the lab classes, you should be very, very careful. You have to wear all the necessary things, especially the mask, glove, everything. So, but this week we converted the lab already through online. Okay. So let's we start our chapter. Today we are going to discuss chapter 2, motion along a straight line. What you understand from this chapter title? Could you please recognize what is written on the title?
Motion along a straight line.
What it means?
I believe it's movement or, in a straight line, like going
Yes,
forward, backward.
yes, that means here we are going to consider only one-dimensional point of view. Because if you just go through the graph, we have x-axis, y-axis, z-axis. Am I right? So here we are going to discuss only the object is moving in a straight line. That means rectilinear motion. The object is moving in a line-wise manner. That means we are going to consider the object is moving in only one-dimensional point of view. Clear? What are the contents
Yes.
today? What are the contents today we are going to discuss? These are all the contents. What is written in that? Position. You are going to get some information about what is position, what is displacement, what is average velocity, what is average speed, instantaneous velocity, average acceleration, instantaneous acceleration, and the 8th point is very, very important. This equation is very, very important for solving many problems in physics 1. So here in this 8th point, that means equation for motion with constant acceleration, we are going to study Phi equation. With the help of the Phi equation, we are going to solve many problems. So you should be very, very careful. Please memorize that Phi equations. That Phi equations are very, very important, and you will get a clear picture inshallah in the forthcoming chapters. And also most of the equation we are going to deal with our lab classes. The data analysis from the data analysis should be carried out with the help of this equation. Clear? Brother, if you have any doubts, immediately once I just give the lecture of the concerned slide, please raise your question. No need to wait. Understand?
Yes.
Inshallah.
Okay, very good. Okay, the last one, we are going to study some basic information about free fall acceleration. Let's we just start our lecture with the introduction. What is given here? In this chapter, we are going to study the concept of kinematics. Have you ever heard the word kinematics? Have you ever heard this word?
Yes.
What it means? What is the what do you understand from this kinematics?
If I'm not mistaken, movement of objects or power of movement.
Yeah, the objects that we are going to study it. We are going. Excuse me, brother. It's my kind advice. Try to avoid sending the messages. If you have any doubts, please ask through mic, because I can't see your message because I'm just seeing the slides only. Understand? So if you have any doubts regarding the consent slide, immediately you can just raise the question, because if you are just frequently send the message, it will be little bit disturbed for me. So please, if you have any doubts, immediately raise the question. Understand? I will be waiting for you. No problem. So kinematics is nothing but we are going to study the object motion. So in this chapter, we are going to deal with the motion along a straight line. That means we are going to consider only one-dimensional point of view. Have you ever heard the word one-dimensional? One dimension.
Yes, that means either X or Y axis.
X, Y, or Z. So anything we are just going to consider in this chapter is nothing but we are going to consider only one-dimensional point of view. And then we are going to study the motion of an object. Here it will be changes its position with respect to time. Based on each and every second, what will be the position of an object? For example, at t is equal to 0, the object is exactly at 0 position. For example, if you just see this, we are just going to consider the position of an object with respect to time variable. So with respect to time, what will be the position of an object? So in this chapter, we are going to consider only the motion, and this chapter is very, very important. Please listen to this chapter very carefully. We are going to study the same concept in chapter number 4, motion of an object in 2 or 3 dimensional. That chapter title is nothing but motion of an object in 2 or 3 dimensional. So if you just understand the concept from this chapter, studying the concept in the 4th chapter will be very easy. So please listen very carefully. Let's start from the topic position. What is position? A position is measured relative to a reference point. You can just see the graph. Here the graph we just mentioned, x-axis, that means the positive x-axis, negative x-axis. So here 0 is our reference. Suppose I'm just standing here. After some time, I'm going to reach this position. So initially my position is at 0, and later on I just move to position 3. So here my x-axis is represented in terms of meter. So if at each and every time, what is my location? That means what is my position? That is written here. The position is measured relative to a reference point. What is our reference point here? Our reference point is 0. So the origin or 0 point of an x-axis must be our reference point. When you just study the concept of this position, you must have either two signs, either it may be a positive sign or negative sign. So positive signs means the object is moving in the increasing number. Negative sign means opposite to the number. Just to see this example, I'm just posting the slides just for giving an example for the position. You can see the person is standing near to the tree and a bus is moving. So the position of a tree is exactly at 0, and the bus is also exactly starting from 0. So thus the bus moved away from the tree. So what you understand from this slide, the person is comparing the position of the bus with respect to the position of a tree. That means here our reference is nothing but the position of the tree. From the tree, how much distance the bus is traveling.
Doctor,
so yes, brother.
The sound is cutting off.
Cutting off?
Yes.
There is another in your sound.
Is it clear or not?
When you talk slowly, we can understand you, but when you talk fast, it cuts off a little bit.
I'm just I'm just talking very slowly. I'm not moving. I'm not saying fast. I'm just moving the slides very slowly.
You have rest in your voice. Rest. You know rest?
What about now? What about now?
It's not
Resonate, teacher. تفضل.
The problem, brother, actually each and everyone is opening your mic. This is the reason. Better you can do one thing. First mute all your mics. If you have any doubts, open your mic and then ask me a question. Understand? If everyone is opening the mic, then this type of disturbance will happen for both sides, that side and this side. Clear? Better you can just mute your mic first.
No,
If you have any
everyone is talking is cutting off the voice, not only you. It's from the blackboard, I think.
from the blackboard, they are sending a message, something. I hear the message sound. Please, brother, it's my kind advice. Please mute all your mic. If you have any question, just open the mic. Understand?
Yes.
Yes.
Okay, good. So here in this slide, you can just see a person is he is standing near to the tree. The position of the tree is right now, we just make the reference as 0. The bus is moving. When the bus is moving, what happened? We have to make our reference point at 0. That is nothing but our position of the tree. With respect to the position of the tree, we are going to calculate the remaining things. So it's very, very important. When you just study the concept of position, the reference point is very, very important. Understand? Now let's come for the topic. Now let's come for the topic of distance and displacement. Could you please tell me what is the difference between displacement and distance? I think you already studied these things in your school life. What is distance?
The distance, the all way that I covered, and the displacement, the straight line from the beginning till the end.
Yes, very good. For example, distance is nothing but how much you are just going to move from one point to another point. So if you just calculate the entire distance, the entire information, then that information gives you the clear picture about the length of the actual path. When you come for the displacement needs two things. The first one is initial position and final position. When you subtract the final position from the initial position, you will get the information about the displacement. Inshallah, in third slides, I will give the example for distance and displacement. If you just come for this slide, displacement, it's a formula. This formula is very, very important. You have to memorize all these formula. What is the formula for displacement? The displacement delta x is equal to x2 minus x1. What is x2? My x2 is final position. My x1 is initial position. For example, I just gave some example. Could you please just tell me the answer? Answer is already there, but you have to understand. The object is moving from 5 meter to 12 meter. Could you please tell me what is the displacement? Final position minus initial position. What is our final position? My final position. Yes, my final position is 12 meter. My initial position is 5 meter. When you subtract 12 minus 5, you will get 7 meter. And the most important thing, the sign. Because here the object is moving only in the positive direction. So here you will get positive direction 7 meter. Understand? And when you come for the second example, the object is moving from x is equal to 5 meter and then it is moving to x is equal to 1 meter. So you can see this is my final position, this is my initial position. When you just subtract here, you can see my final position is 1 meter, my initial position is 5 meter. What will be the answer? Minus 4 meter. So here the object is moving in the negative direction of the x-axis. When you come for the third example is very, very important. Here we just give 3 locations, 3 positions we are giving. Initially the object is moving from 5 meter and then it is traveling up to 200 meter and then the object once again it will be came back to 5 meter. For example, here the location is 5. Here the location is 5 meter. The object is moving up to 200 meter and then again it is returned back to 5. So what will be your final initial position? My initial position is 5. My final position is also 5. So 5 minus 5 gives you 0. So when you just come for calculating the displacement, you should not consider the intermediate one. You have to consider the initial as well as the final. Understand? Could you please tell me
Yes.
what is the? Could you please tell me what is the answer for distance? Can you please calculate the distance for the third category?
Could you repeat the teacher?
Could you please tell me what is the distance for the third category? X is equal to 5 meter. It is moving to 200 meter and it is come back to 5 meter.
0.
200.
No, 200.
Displacement is 0. What is distance? How much distance you are covering?
400.
190.
Huh?
400 meters.
410.
Complete distance. So you can see you are just moving from 5 meter to 200 and then again you just return back to 5 meter. That means 200 meters you are traveling
400.
and then you return back to again that means 95. So 195 plus 195. Am I right or not?
Yes.
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 So in this category, you can see the information given in red color.
390.
Your distance is not equal to displacement. So when the object is moving in only one direction, it's no issue. When it is moving and coming back, by the time your distance is not exactly equal to the displacement. So here your displacement is a vector quantity. What is the meaning for vector quantity? Have you ever heard about this word vector?
No.
What is vector? I think you studied in school in your physics subject in your school life.
Is it
like
Vector, vector gives you both
Displacement.
direction?
magnitude and
Teachers, I think the distance it's mean the way when the person go.
yes, the total distance.
Yeah, it's important.
Yes, very important. Whether
390.
Like northwest, northwest, east.
Distance, brother, listen carefully. Your displacement is a vector quantity. Your distance is a scalar quantity. What is the difference between scalar and vector? Your vector gives you both magnitude and direction. But when you come for scalar, it will be give you only magnitude. So there will be no distance, no direction. So when you are just talking about the distance, it will never give you the direction. But when you just study the concept of displacement, you will get both information, magnitude as well as direction. So when any parameters gives you both magnitude and direction, then you have to say it is a vector quantity. If anyone gives only the magnitude, then you have to say it's a scalar quantity. So distance is a scalar quantity, displacement is a vector quantity. Clear?
Clear, teacher.
Okay, you can see this example, you will get a clear idea. You can see Rohit and Seema, the two persons, both started from their house. So initially they start from the house. Rohit walks 2 kilometers to the east. So Mr. Rohit is walking 2 kilometers to the east, and while Seema walks 1 kilometer to the west and turn back 1 kilometer. So that means Seema is moving 1 kilometer to the west and then again she turned back moving 1 kilometer to the east. Now what is the distance traveled by both of them? How much distance Rohit covered? How much distance Rohit covered, brother? I'm just asking.
2 kilometers.
Okay. How much distance Seema covered? Seema is moving 1 kilometer to the east and then 1 kilometer to the west. That means a total 1 kilometer here, 1 kilometer here. What is the distance here?
0.
2.
How will the distance become 0, brother? I'm talking about the distance.
2.
2 kilometers.
So both of them have the same distance. Am I right?
Yes. Yep.
Okay, let's come for the displacement. Is there displacement also same?
No.
It's not possible. For example, you can see here.
No.
This is Seema. For example, I just draw this diagram. This is Rohit. For example, I can just write Rohit moving to 2 meter. So he reached 2 meter. So what is the distance here? My distance for Rohit is 2 kilometers. Sorry, is 2 kilometers. I have to put K here. And what is the displacement? What is the displacement, brother?
2 kilo also.
See here.
2
See here.
kilometers.
This is my final position. This is my initial position. He is starting from 0. Am I right?
Yes.
So final position minus initial position gives you the displacement. So what is the displacement for the Rohit? The displacement for the Rohit is again
2 kilometers.
2 kilometer. Okay. Let's we come for a Seema. What Seema did? Seema she is moving 1 kilometer and then
And
she
return.
returns back 1 kilometer. So that means 1 kilometer this direction, 1 kilometer this direction. So her distance is 2. Am I right?
2 kilometers, yes.
Distance is 2 kilometer. But what is the displacement?
0.
Why? Because final minus initial. So it gives you 0 kilometer. So now I think you will understand the concept, the difference between the distance and the displacement. So you should be very, very careful. Your displacement is not always equal to distance. Sometimes it may be the same, but most of the case, it will not be exactly the same. Understand?
Yes.
Now we come for the topic speed and velocity. So what is the formula for speed? The formula for the speed is nothing but how much distance you covered. I think we already studied this formula in chapter number 1. So what is the formula for this, the speed? Distance covered over time. So the unit for distance is meter. The unit for time is second. So we have to say the speed unit is meter per second. Likewise here, your speed is a scalar quantity. Your velocity is a vector quantity. What it means scalar here? Here it gives only magnitude. What is here? It gives both magnitude as well as direction. So formula is different. The speed formula is distance over time, but what is the formula for velocity? It's a displacement over time. What is the formula for displacement, brother? What's the formula for displacement? x2 over x1 over t2 minus t1. But the unit remains the same for both the case, because the distance is also measured in terms of meter, displacement also measured in terms of meter, and the unit for time is second. So when you just see the concept of speed and velocity, your speed is a scalar quantity which is always positive value. But when you come for the velocity, sometimes it may be a positive value, sometimes it may be a negative value. What the positive represent? The positive represent the object is moving in the positive x direction, and the negative represent the object is moving in the negative x direction. So here, when you just calculate the velocity, velocity is a vector quantity. It will give both information about how much distance it is covered. That means magnitude. Also, it will be give the direction also. So when an object is traveling along a straight line, its velocity is equal to speed. I told you just before. When the object is moving on a straight line, your velocity must be equal to the speed. Both gives you the positive value. Understand?
Doctor,
Yes, brother.
I have question.
Yes, please.
Distance always positive or not?
Brother, distance, actually the speed, the formula for the speed always gives you the positive value. Always the distance is the positive. Okay. Okay, I will give one example. When you just see that example, you will get a clear picture. Just wait for a minute. Okay. And the next slide, I give the example. You will get a clear picture. I told you the distance is a positive, always positive, but your displacement sometimes it may be positive or negative. Clear?
Clear.
Okay.
Teacher,
Now, yes, brother.
what's the difference between speed and velocity?
The speed is a scalar, velocity is a vector. Only this difference. That means it gives you, this is a scalar quantity. What is scalar? Brother, this is a 1-mark theory question. Define scalar and vector. What will be your answer? If I ask the question, define scalar, define vector. Scalar quantity is a quantity which gives you only the magnitude but no direction. But vector is a quantity which gives you both magnitude and direction. Clear, brother? This is 1 mark theory question. Define scalar quantity. Define vector quantity. But the scalar quantity is a quantity which gives you only the magnitude. There will be no direction.
In velocity, I have 2x, right?
Yes.
Okay.
So when the object is moving in the x direction, then you have to say plus 2 meter. When the object is moving in the negative direction, then you have to say minus 2 meter. So the displacement, sometimes it may be positive or negative, but when you come for the concept of distance, your distance is always positive. So we just see the third slide, then by the time we get a clear idea. So here the formula for velocity, we already studied. What is the formula for velocity? What is the formula for velocity?
Displacement divided by time.
So what is here? What is here?
Displacement.
We studied this is
The change of
change in position. Clear? So change in position over change in time. We already studied this formula. Okay. Here you can just see average speed is nothing but total distance over time. Here I gave an example. You can just tell your answer. Answer is already there. But let's just read the question first. What is given in the question? A particle moves from x is equal to 3 meter to x is equal to minus 3 meter in 2 seconds. Could you please calculate what is its velocity? What is its velocity, brother? What's the formula for velocity? What's the formula for velocity?
Displacement over time.
What is displacement?
Sorry. The
Final
position.
Final
minus
initial.
Okay. In this question, which one is the final? This is our
Minus
final
3.
position. This is our
Minus
final
3.
position. Am I right?
Yes.
This is our initial position. Okay. Could you please write in the formula? Delta
Minus 3.
Delta, that means minus 3.
Minus 3 minus 3
divided by 2.
divided by 2.
So this becomes minus 6 over 2. This gives
Minus
you
3.
minus 3. So you can see here my velocity. That means the object is moving in the negative direction of x and its unit is nothing but meter per second. Let's come for calculating the speed. What is the answer for speed? What is the formula for speed? Total distance over
Total
time.
distance divided by time.
Okay, what is the total distance? Here 3 kilometer, here 3 kilometer. So what is the total?
6.
So that means 6 over 2
divided by 2, 3.
So I told you just before, your speed is always positive. Am I right?
Right.
And your displacement, sometimes it may be positive, sometimes it may be negative. It depends upon the position of an object. Clear?
Doctor.
Yes.
yes.
The displacement. It mean go north, right?
Brother, it is not north-south. Of course, there must be some
displacement
direction.
معناها الإزاحة. مسافة مع اللي هو اتجاه.
Either it may be moving in positive direction, negative direction, north, south, east, west, but it has some direction. Understand?
Okay.
Doctor,
Yes.
is it always the distance is larger than the displacement?
Sometimes it depends upon the position of an object.
Okay.
For example, you can see here, I put 5 here. For example, instead of minus 3, I put 5. What should be your answer, brother? 3 plus 5?
For the displacement or?
Both. You can just give the answer for both.
8 and it mean minus 4. Minus 4.
Oh, minus. So is it same?
4.
So your displacement and the distance depend upon the position of an object. It will not be always exactly the same value. Do you get my point?
Yeah.
Okay, now we come for the concept of instantaneous velocity or speed. What does it mean for instantaneous?
And one moment.
Okay. Now I will ask you a question. What is the distance from Jubail to Dammam? Approximately 100 kilometers. We'll just take 100 kilometers. Okay? Okay,
80
for 70
kilometers.
Okay, let's come for your answer. Okay, the distance from Jubail to Dammam is 70 kilometers. Am I right?
Yes.
Okay, you are traveling from Jubail to Dammam. In between, you have different speed level. Am I right? It's depend
Yes.
upon the traffic time. Your speed will be decreased. Sometimes you will increase your speed. Am I right or not? So at
Yes.
the time t is equal to 0, your initial position is 0. Am I right?
Yes.
At a time is equal to 5 seconds, your speed is little bit faster. At time is equal to 3 seconds, you will just little bit reduce the time, reduce the speed. So time by time, your speed is different. Am I right or not?
Yes.
So here, when you just come for the topic of instantaneous velocity, you have to go for a particular time. At this time, what is my speed? At a time t is equal to 5 seconds, what is my speed? At time t is equal to 10 seconds, what is my speed? So your speed will not be the same. Am I right or not?
Yes, you mean the speed in this specific time.
So that's what we mentioned. What is mentioned here? At a single moment of time. So for each and every second, what will be your velocity? What will be your speed? So for the average speed, we have this formula. But what's the difference here? We have to use the formula for calculating the instantaneous velocity or speed with the help of this dx over dt. I think you already finished your calculus 1. Am I right? Have you finished your calculus 1?
No, teacher. We are
most of
Okay. Okay. What is the rule? Have you ever heard about this rule? D over dx, x d over dx, x power n. What's the rule, brother?
derivative n x n minus 1.
Am I right or not?
Yes.
So when you just about to calculate the speed, instantaneous velocity or instantaneous speed, you have to use this rule. Okay, here I gave some example. You can just read the example. The following equations gives you the position with respect to time. That is nothing but your x over t, x of t. Clear? Of a particle in 4 situations. I have 4 cases. What are the cases? My initial position is, the initial position is this. My second position is this. Third position is this. My fourth position is this. Clear? Now, in which situation the speed of an object is constant? What is the meaning for constant?
Stable.
What's the meaning for the constant? Some number.
0.
Some number.
That's the
Some
same.
number is nothing but your constant. Right? It's not only 0. Some number is nothing but constant. Okay. So I have 4 situations. What is my first situation? My first situation is x is equal to 3t minus 2. Am I right? Am I right or not?
Yes.
Could you please apply this rule for this? What is the power of t? What is the power of
1.
t here? 1. Could you please apply this? What you will get? If you differentiate this value, you will get only
3.
3. If you differentiate any constant,
0.
0. So whenever you are differentiating the constant, which gives you the value of 0, but whenever you have any variable, that means here we are just differentiating our position with respect to time. When you apply this rule, what you will get? I will get only 3. Am I right? So 3 is nothing but constant. Am I right or not?
Yes.
Okay, let's go for the second situation. This is my first situation. What is my second situation? X is equal to minus 4 t square minus 2. Apply this rule. If you apply this rule, what you will get?
Minus 8
Minus 4.
t.
Minus 8t. Am I right or not?
Yeah.
Yes.
Is it a constant? Minus 8t is a constant?
No.
It's not a constant. Okay. Let's go for our third category. What is given in a third one? X is equal to 2 divided by t square. Am I right? How I can write? I can write this as 2t power minus 2. Am I right? I can write like this. Am I right or not?
Yeah.
Yes.
Okay, if you just write what you'll get, could you please apply the rule? Now my n value is -2. That means this becomes -4.
minus 3.
3 power -3. Is it a constant?
No.
No. Okay, let's we go for our fourth situation. What is given in our fourth situation? X is equal to -2. If you differentiate this, what will be the answer, brother? Differentiation of any constant, what I told you just before. Differentiation of any constant gives you
0.
0. It is also a constant. Am I right? Okay. In this fourth situation, how many situations gives you the constant value?
1 and 4.
1 and 4 gives me the constant. Am I right?
Yes.
And how many situations will give you the negative value? Situation 2 and situation 3 gives you the negative value. Am I right? So this will be the answer for the first question. This will be the answer for the second question. Understand? So please, brother, don't forget this rule. This rule is very, very important. X power n minus 1. When you differentiate any parameter with respect to x, then you will get this answer. Understand? Understand?
Yes, clear.
Teacher.
Yes.
Teacher.
Yes.
I don't understand step 3.
Okay. Step 3. You don't understand, huh? Okay. What is your third step, brother? My third step is x, which is equal to 2 divided by 3 t square. Am I right?
Yeah.
How you can write this, brother? In mathematics, how you can write? I can write the above one like this. Because my t is in the denominator, I can take it to the numerator like this. Am I right?
Yes.
So now what is the value of n here?
-2.
Okay, apply this rule for this. If you apply this rule, what you'll get? Minus 4 t power -2 minus 1. So -3. Clear?
Clear.
That's it.
Yeah. Thanks.
Welcome. Okay, now we come for the topic of average acceleration and instantaneous acceleration. What is average acceleration? Again, you have to see the formula. It is particle speed or velocity. What is our velocity? What is the formula for velocity? Delta x over delta t. Am I right? Am I right or not?
Yes.
What is the formula for acceleration? Acceleration is nothing but it's depend upon change in velocity over change in time. So what is the meaning for velocity, brother? It is v2 minus v1 over t2 minus t1. So here, when you are about to calculate the average acceleration, we have to use this formula. When you come for the instantaneous acceleration, it's exactly the same method, but with respect to a time moment. For a single moment of time, what is my acceleration? So here, when we just see this concept, sometimes we may ask the theory question. Your object acceleration, your object has the acceleration only if the speed is changing. Am I right? If your speed is changed, your acceleration will change. Am I right or not?
Right. Okay.
You are driving the car. When you just you are pushing your acceleration pedal, your car speed will be increased. Am I right or not?
Yes.
Yes.
When you just release your leg from the acceleration pedal, what is your speed? It will be increased or decreasing?
Decreasing.
Decreasing. So your object accelerations depends on only if the speed is changing. If the speed changes, your acceleration will change. Not only the speed, it will be depend on the direction also. If you change the direction, then your acceleration will be changed. Suppose you are taking left, right. So what will be your speed? When you take the right direction, left direction, your speed will be changed. Am I right? When the speed will be changed, your acceleration will be changed. So it will be depend on your speed is when you change the speed, your acceleration is different. When you change the direction, your acceleration will change. When you change both the speed and the direction, then it will be changed. So these 3 points are very, very important for 1 mark theory question. Sometimes you may ask the question, an object has an acceleration dash. You have tried. If the object has an acceleration when it has the speed change, direction changing, and both speed and direction change. Clear? So this is our 1 mark theory question. Sometimes we will ask the numerical, the multiple choice question. Sometimes you will face this type of question in your multiple choice question. Clear?
Yes.
Okay. Let's come for this equation. This equation is very, very important. This equation is very, very important. Please, brother, memorize this equation. Equation for motion with a constant acceleration. How many equations we have? How many equations we have?
5 equations. 5.
5 equations. Okay, let's just see the first equation. V, which is equal to V naught plus AT. What is your V, brother, here? My V stands for final velocity. Am I right?
Velocity.
Yes.
Final velocity. What is V naught? My initial velocity.
Initial.
What is my A?
Acceleration.
Acceleration. What is my time? What is T? T is nothing but time. So far, what are the things we learned, brother? Could you please recall what are the things we learned so far in this chapter? We studied the concept of displacement, am I right?
Yes.
We studied the concept of speed, velocity, am I right?
Yes, and the difference between velocity and speed.
Yes. And then we studied the concept of acceleration, am I right?
Yes.
And we study the concept of time, because time, with respect to time, both will be changed. Because in the first slide I told you the motion of an object will be changing with respect to the time. So when you just come for the displacement, you have 2 information. What are that? Final position, sorry, initial position, final position. Am I right? Likewise, velocity, final velocity. Velocity, when you come for velocity, final velocity, initial velocity. Clear? So if you just see this equation, when you just see the first equation, I have the final velocity, I have the initial velocity, acceleration I have, time I have, but only one parameter is missing. What is that?
Displacement.
Displacement is not there. Am I right or not?
Yes.
What is the beauty of this phi equation? For sure, one parameter will not be there. When you just see the first equation, we have the final velocity, we have the initial velocity, we have the acceleration, we have the time. But which one is missing? Our displacement is missing. Am I right?
Yes, the displacement.
Okay, let's come for the second equation. In the second equation, I have the displacement. Am I right or not? What is this?
This is the displacement.
Final position minus final position is x. My initial position is x naught. What is v naught? What is
Initial velocity.
Initial velocity. What is
initial
t?
velocity, yes.
What is t?
Time.
Time. What is a? Acceleration. So here, which one is missing? Is there any initial velocity, final velocity?
No.
No.
So
the final velocity is missing.
Yes, so in this case, my final velocity is missing. Okay, let's come for our third parameter, third equation. What is given in the third equation? V square. That means my final velocity square, which is equal to my initial velocity square plus 2 acceleration multiplied by the displacement. So if you just see this equation, our time parameter is not there. Am I right or not?
Yes, you're right.
Exactly, yes.
Okay, let's cover our fourth equation. What is our fourth equation? X minus x naught is our displacement, and we have initial velocity, we have final velocity, we have time. Which one is missing?
Acceleration.
missing. Okay, let's come for our last equation, x minus x naught, which is equal to v naught vt minus half at square. So brother, how we got this equation? Okay, for the first 4 equations, no problem, it will be very easy. But how we got the 5th equation?
The initial velocity missing.
Wait, I will just show you how, because the last equation we have to, what is our last equation? For getting this last equation, you have to use the first 2 equation. What is our first equation, brother? This is our first equation, am I right?
Yes.
What is our second equation? This is our second equation, am I right?
Yes.
From the first equation, I am going to calculate my initial velocity. How we can calculate this initial velocity? How you can calculate the initial velocity?
To move the final.
Okay, that means my v naught, which is equal to v minus at. Am I right?
Yes.
Okay, now what I am going to do, I am going to take this v naught, I am going to substitute here. If you substitute in the second equation, what you will get? X minus x naught as it is. Am I right? Am I right?
Yes.
Which is equal to, in this place of v naught, I am going to substitute this. So what you will get? V minus
at
multiplied by t. Am I right? Plus
yes,
half at square. Understand? If you just multiply inside, what you get, brother? This becomes vt minus at square. Am I right?
yes,
Plus half at square. Left hand side, I have x minus x naught. Am I right?
yeah,
Am I right or not?
yes,
Okay, now I have minus 1 at square, I have plus half at square. So minus 1 plus half. So what you will get? Vt
minus
half at square. Am I right? Left hand side,
yeah,
x minus x naught. So you can see our last equation is come from the first 2 equation. Clear?
yes, clear, doctor.
So brother, sometimes why I'm just saying all these things, the first 3 equations are very, very important. Generally, most of the example will cover from this first 3 equation. But in some cases, if you are using this 4th equation and 5th equation, sometimes the problem solving will be very easy. Understand? So please memorize these 5 equations. If you memorize these 5 equations, solving the problems in physics 1 will be very easy. Most of the chapter, inshallah, when we are about to calculate, when we are about to discuss the problem question in this chapter, you will know the importance of this equation. So please memorize this equation. Sometimes we may ask one more question. Write down the equation of the motion with constant acceleration. Write down any 2 equations of motion with constant acceleration. How many equations here we have? We have 5 equations. Out of this 5 equation, you can pick any 2 equations. So please read the question before you answer. Suppose if you ask, write the 5 equations of motion with constant acceleration, you have to write the entire 5 equations. So better, please memorize all these 5 equations. That will be quite good for your exam.
Doctor?
Yes, brother.
Can I write VF instead of V and VI instead of V naught?
No problem. So that means you are asking here, like this, VF, this is VI, am I right?
Yeah.
No problem, it's right, both are same. If you write VI, means it is initial velocity. If you write V naught, means it is initial velocity. So either you can use 0, or either you can use I, no problem. Understand?
Yeah, thank you.
Okay. Now, this is our last slide regarding the free fall acceleration. What is our free fall acceleration? our free fall acceleration. That means, what is the meaning of free fall, brother? Have you ever heard this word free fall?
سقوط الحر.
Yeah, when object dropped from
Flies any object up to certain height, and then we are going to leave this object. What will happen? The object will be move very easily towards the gravity. Am I right? So when any object is moving freely towards the gravity, then we have to say that is nothing but free fall acceleration. So the free fall acceleration is also called as acceleration due to gravity. So what is the meaning for free fall acceleration? The free fall acceleration is the rate at which the object accelerates due to the force of gravity. So these 3 points are very, very important. The object, so you are
accelerate 9.8 a second.
Yes, so we know the value of g. What is the value of g? 9.8 meter per second. Okay, here your acceleration due to gravity is always
down.
For example, I am on the ground. I'm just, what happened? I'm just having
ball.
I am having the ball in my hand. I'm having the ball in my hand. I'm going to throw in the upward direction. If I just throw in the upward direction, what will happen? What is the value of g here? What is the value of g?
It will decrease.
No, so that means this is minus 9.8. Am I right or not?
9.8. It will decrease.
So this is nothing but minus 9.8. When it comes down,
it's plus 9.8.
So read the question and then give the correct answer. If the object is moving away from the gravity, then you have to use negative of 9.8. When the object is moving towards the downward direction, then it carries the positive of 9.8 value. Understand, brother? So these are very, very important. And the second point is very, very important. So when you just study the concept of free fall acceleration, it's a constant because we have the constant value 9.81. And the most important thing, it is independent of the property of an object. What is the independent? It does not depend on the mass. It does not depend on the density. It does not depend on the shape. For example, if you take a square ball or if you take a rectangular ball, a rectangular block, you just to throw from the top, what will happen? It will be accelerated only at the speed of 9.8 meter per second square. So here it is totally independent. It does not depend on the mass. It does not depend on the density of the material. It does not depend on the shape. So it is totally independent. When you are about to study the concept of free fall acceleration, it is a constant value. What is your free fall acceleration? Your free fall acceleration is nothing but the acceleration due to gravity. It is nothing but the rate at which the object is accelerated due to the gravity force. It is always downward direction. You can see the picture. The apple is falling downward direction. Also, I have a feather. So that means what is the mass of this apple, brother? What is the mass of this apple? What is the mass of the feather? Is both are same?
No, the ball is heavier.
No, the ball is heavy. The ball is heavy, but the feather is very light. Am I right? So when you just do this experiment in the vacuum place, what will happen? Your feather and the apple will accelerate exactly the same value of 9.8. The most important condition, you have to do the experiment in vacuum. First of all, you have to remove all the air particles. Then only you will get 9.8. If you are not doing the experiment in this condition, then your G value is different. I think this will be your first experiment, inshallah, in your physics 1. When you are just doing this experiment, you will get a clear picture because you are dropping the ball. When you are about to drop the ball, what will happen? Your G value will not exactly 9.8 because we have some air resistance. You get my point? When you remove the complete air, then you will get the exact value of 9.8. Clear?
We have another factors that can affect the result. For example, the air.
Okay.
We have another factors can affect the result.
Yes, of course, because we have the air resistance only in the smaller level, not in the greater level. So that's what I told you. You will not get the exact 9.8. Sometimes it may be less than, sometimes it may be greater than 9.8. You get my point? Yes. This is because of the air resistance.
Throw a bowling.
What, brother? Could you please repeat the question?
I told you when I throw a ball, heavy ball, or I throw paper. The
Okay.
wind may affect the falling for the paper, so the speed will not be the same.
So, brother, listen carefully. You take a paper, you take the metallic ball. When you just do this experiment in the vacuum place, suppose you remove all the air molecules from the room. When you just put these two objects from some certain height, what will happen? Both objects will have the same value of, will have the same value of 9.8. If you don't remove these air molecules, what will happen? Then it will be different, because we have more air resistance for the paper, we have less resistance for the heaviest ball.
Teacher,
Yes.
because in this situation, the density doesn't make any right?
The density does not affect. That's what it's clearly mentioned. It is independent. What is the meaning for independent? It will not depend on the density. Even if it is a heavier density or even if it is a lesser density. When you just carried out this experiment in the vacuum place, then you will get the same value of 9.8. Understand?
Yes.
Clear?
Yes.
Okay. Now, could you please recall what are the things we discussed today? We studied the concept of position. Am I right?
Position.
We studied the concept of position. We studied the concept of displacement, not density. Displacement. What's the formula for? Okay, what is the formula for displacement?
It's
Displacement
the difference between the position and the first position.
Okay. What is the formula for velocity?
Distance over time. No, displacement
over time.
Fine, good. What is our displacement? Our displacement is delta x. Our time is delta t. Am I right? This becomes x2 minus x1 over t2 minus t1. Am I right?
Yeah.
Okay. What is the formula for speed? Average speed.
Distance divided by
Distance
time.
over
the time.
Over time. Good. So that means the total distance you have to take. Understand?
Yes.
And then instantaneous velocity. What is the formula for instantaneous velocity? It is nothing but dx over dt. So what is the formula for acceleration?
Speed over
change in velocity over change in time. So which is nothing but v2 minus v1 over
T2 minus T1.
T2 minus T1. Am I right? And then we studied the instantaneous acceleration. What is instantaneous acceleration? Instantaneous acceleration, which is nothing but dv over dt. What that means? Finding the change in velocity with respect to some time, at some single moment of time. So here you have to use this formula. What is the formula? X power n rule formula. What is the x power n rule formula, brother? N x power n minus 1. Am I right?
Yes.
So don't forget. And what are the phi equation? We studied phi equations of motion. What is that? V is equal to v naught plus at
minus
x minus x naught, which is equal to v naught t plus half at square. Third equation, v square, which is equal to v naught square plus 2 into a into x minus x naught. Am I right? Displacement x minus x naught, which is equal to the average speed. That means 1 over 2 times of v plus v naught t. Am I right? And the last equation is x minus x naught, which is equal to vt minus half at square. So these phi equations are very, very important. So you can just see, brother, how many formulas we learned from this topic. We studied many formulas. So please memorize all these things. Clear? Clear? Shall we go for solving the problems? Shall we go for solving the problems? Okay. So these are all the problems we are going to discuss for this chapter. I think out of 5 problems, let's we just first discuss 1 or 2 problems. The remaining problem, inshallah, we will leave it for Wednesday class. Clear? I don't want to make more information by today. Otherwise, it will be totally confused. For today, like.
Okay, that's good.
Okay. Read the question.
Sorry, Doctor, can you repeat because the voice wasn't clear?
Actually, we are going to solve 5 problems for this chapter. That means for chapter 2, we are going to discuss 5 problems. Okay. And inshallah, we have one more classes on Wednesday. Am I right?
Ah, okay. Yeah.
So what I'm inshallah remaining 3 problems on Wednesday.
Oh, okay. I got
Understand?
it. Yes.
Okay.
Yes.
This is our first question. Could you please read? Do you have a calculator in your hand?
Yes, I have.
Yes, I have.
Brother, yes, please, because I need the answer from your side. Understand?
Sure. Yes.
Okay, you can see. Read the question. A car travels up the hill at a constant speed of 35 km per hour and returns down the hill at the constant speed of 60 km per hour. Calculate the average speed for the round trip. What is the formula for average speed? What is the formula for average speed?
Distance
for
over
average speed.
Total distance.
Total distance over total time. Am I right?
yes.
Right.
Yeah.
So, am I right or not? So the formula for
Yes,
average
right.
speed. First I just write. Okay. Better we can just write the formula first, and then we will just write one by one. Average speed is equal to total distance over
Total time.
total time. Am I right? Okay. Now I will just draw the diagram. This is the hill. Clear? The
Yeah.
car. I just draw a car. Oh, what happened?
25 divided by 2.
Wait. So the car is moving the hill like this, and then it is coming like this. Am I right?
Yes.
Am I right or not?
Right.
Now this is the distance for the for moving from top to bottom to top, and this is the distance moving from top to bottom. Am I right?
Yep.
Am I right or not? And then
Right.
when the distance, so what are the things given in the question? It is moving up the hill at the speed of, that means speed up. What's the speed up?
35.
kilometer per hour. Clear?
Yes.
What is the speed down?
60 kilometer per hour.
60 kilometer per hour. Clear? Okay. Now these two informations are given, but the information for the distance is not given. Am I right? But when you just see the hill, the distance from bottom to top and top to bottom remains the same. Am I right?
Yes.
So I can just write the distance up plus distance down, which is equal to d plus d. Am I right? divided
Yes.
by total time. That means time up plus
1 hour for going.
time down. Am I right? So I can just write these as
Yes.
T up plus T down. Am I right?
Theta.
Okay. What is the value of D plus D? My D plus D is nothing but 2D.
Yes, okay,
Am I right?
2D. Yes,
95.
1D plus 1D gives you 2D. Am I right?
Yep, yep.
Okay, then which is equal to, because we don't have the value of this time up, but we know the formula. What is the formula for distance, brother? What is the formula for distance? What is the formula for distance? We know distance is equal to speed, which is equal to distance over time. Therefore, distance is equal to
speed multiplied by distance by time.
that means my speed divided by sorry. I have to. I just made
Speed multiplied by T.
wait. Because we don't have the value of time, so I have to. Brother, could you please turn off your mic? Brother, could you please turn off your mic? If you have any doubts, please ask me. Otherwise, it's really noisy here. Okay. So we know the speed is equal to distance over time. Therefore, time is equal to. Distance over speed. Am I right?
Yes.
Am I right? Okay. In this place, what I am going to do for this timer, how I can just write? I can write distance divided by speed up. Am I right? Am I right? For this, I just write like this because my time up is nothing but distance over speed up. Am I right? Because I am using this rule. Understand? Understand? That means T up, which is equal to my distance is D. What is my speed? Am I right?
Yes.
So I can just write like this. Okay, what is the answer for T down? What is the answer for T down? Same like this. This is D divided by V down. Am I right? Am I right? For this. Clear?
Yes, yes.
Yes,
So I can just write 2D over, I can take D as a common outside. Am I right? Is it possible or not?
Yes, of course.
So 1 VF plus 1 over
V down.
V down. Clear? Now this D and this D get cancelled. Am I right?
Okay.
So I have the remaining value 2 divided by 1 over, what is the value of VF? VF already we have in the question. What is the value?
35.
So I can just write 35 kilometer per hour plus 1 over
60.
60.
1
Am I
over
right?
60.
Could you please
Yes.
use your calculator and let me know your answer?
Doctor,
Yes.
I have a question.
Yes, please.
Why you delete D?
44.
We have 2D, teacher.
What?
We have 2D.
Brother, this is a basic division. I have 2 multiplied by D divided by D. Am I right? So I can just cancel only D, this D. Am I right? Remaining only 2 is there. I just write it here.
Then we will have 1D, teacher.
What 1D? Yes, of course.
لا تقسيم تروح الدي يبقى 2 بس.
Brother, what is the answer for this? 2D.
44.21.
Okay, no, brother, let's, just a minute. Okay, what is the answer for this? You can just cancel these D and D. What is the remaining?
Not D, teacher.
D will get cancelled, brother. Only 2 is remaining. Clear?
Yeah.
Okay, what is the answer, brother? Please let me know the answer.
44.21.
44.21. What's the unit? Kilometer per hour. If we ask you to convert it to meter per second, then you have to multiply by 1000 in the top and you have to multiply 360 in the bottom. Understand? Brother, if you convert the kilometer to meter, how much, what you have to do? You have to multiply by 1000, am I right?
Yes.
Or if you convert the hours to second, 60 multiplied by 60, which is nothing but 3600 will come to the denominator. Am I right or not? So, but anyhow, we can just leave the answer in terms of kilometer per hour because they give the speed in terms of kilometer per hour. So I can just leave like this. Clear?
Clear, yes.
Clear.
Okay.
So you can see our answer is perfect. Same answer. Understand? Any doubt?
Yes.
Shall we go for the second question?
Yeah.
Yep.
Yes.
Okay. It's very easiest question, but you should be very careful while you solve the easiest question. Sometimes most of the student, you will lose the marks because of your overconfidence. So you should be very careful when you are about to solve the easiest question. Clear? Okay, let's read the question. What is given in the question? The displacement of the particle moving along an x-axis is given by the equation. What is given here? Better we just write the given first. What is given in the question? The displacement of the particle equation is given. X, which is equal to 18t plus 5t square, where x is in meter and t is in second. What is our first question? Calculate the instantaneous velocity at time t is equal to 2 seconds. What is the formula for instantaneous velocity? What is the formula for instantaneous velocity? What's the formula for instantaneous velocity? Brother, I'm asking you only.
dx over dt.
Over dt at a particular time. What is our time here?
Or
2 seconds. Alright. So first I'm going to find what is my instantaneous velocity. After I find, I'm going to substitute t is equal to 2 seconds. Understand? So we are going to use this rule. What is the rule? X power n. What is the rule, brother? Clear?
and x with the power of
I'm
n.
going to differentiate this equation with respect to time. So what you will get? Apply this rule here. What is the value of t here? Here we have the t value is 1. Am I right?
Yes.
So if you apply this rule, I will get 18. Am I right?
Yes.
plus differentiate the second part. 10 multiplied by
10 t.
Alright. So my instantaneous velocity is this, but they give the time value. What's the time value? What's the time value? What is given here? 2 seconds. So now I'm going to apply the 2 seconds here. So if t is equal to 2 seconds, then my instantaneous velocity becomes 18 plus 10 multiplied by 2, which is equal to 18 plus 20 gives you 38. What's the unit for velocity?
Meter per second.
That's it. This will be the answer for the first question. So that means this is the answer for the first part.
Okay, teacher, what about in the first part, x equals 18t?
18t plus 5t square, both.
Yes, but why we don't add the first t?
Because when you just differentiate this t is gone. This t is gone. When you just apply this rule, for this equation, this t will gone. Am I right?
Yes.
So you will get only 18, but when you differentiate the second part, you get 10t. Am I right? So you can multiply only 2 here. There is no t in the first part. Am I right or not?
Yes, I got now.
Do you get my point?
Yes.
Okay. Now let's become for the second question. What is your second question?
Doctor, how
Yes,
the
yes,
5
please.
become
How?
and the 18 plus 10t? How the 5
Okay.
become?
Okay, second part. 5 multiplied by 2, because my 2 is the power of t power of 2 minus 1. Am I right? So when you simplify this, you will get only 18. T power 0 is 1. Am I right or not? T power 0, 1 minus 1 becomes 0. So t power 0 becomes 1. Am I right? So am I right or not?
Yes.
Plus
You're always right.
5 multiplied by 2 becomes 10. 2 minus 1 becomes t. That's what we
So
got.
teacher, every limit we make a derivative
Yes, you have to find the derivative.
for each limit.
For each value you have used each parts, you have to apply the derivative. Here in this question, how many parts we have? We have 2 parts. One is 18t, another one is 5t square. Am I right?
Two. Yes.
So you have to apply this rule for each and everything. First you have to apply this x power n for 18t, and then second you have to apply x power n for 5t square. Clear?
Teacher, just for instantaneous velocity.
This is only for instantaneous velocity. If you have this word instantaneous, then only you have to go for this formula, then only you have to go for this rule. If it is average velocity, please don't write this. If you write the formula for average velocity like this, totally wrong. Clear?
Yes. It's clear now. Yes.
Okay. Now let's go for the second. Question. What is given in the second question? What is given in the second question?
The average velocity.
So better I can erase all these things and then we'll go for the second part. What is given in the second part? Average velocity. What is the formula for average velocity, brother? Average velocity. Delta x over
delta x over delta t.
That means this becomes x2 minus x1 over t2 minus t1. Am I right? So now first we have to find what is our x2, what is our x1. Clear?
Yep.
Clear. But our time is given. What is our time 2? Our time 2 is 3 seconds. Our time 1 is 2 seconds. Clear? So time information is already given. The only thing we have to find x2 position and x1 position. We have the basic equation. What is the equation given in the question? X, which is equal to 18t plus phi t square. Am I right?
Yes.
So if you substitute t1 for this part, what you will get? My x1, which is equal to 18 multiplied by, what is the value of t1?
2.
2. Sorry.
What happened?
Mistakenly attached something. Okay. So t value is 2.
Okay, teacher.
Plus 15. What is the value of t1? 2 square. Am I right? So 18 multiplied by 2.
Teacher, doctor, 5,
Yes.
not 15. 5.
Oh, sorry. So it is not. It is only 5. So I can just remove. Okay. What's the total? Correct.
56
meters.
Yes.
Because they clearly mentioned x should be in meter.
Yes, that's right.
Okay. What is our x2? Same method. What is our x2? Our equation is 18t plus 5t square. Now what is our t value? 3 seconds. Am I right? Here what is our t value?
2.
So if you substitute t is equal to 3, this becomes 18 multiplied by 3 plus 5 multiplied by 3 square. Am I right?
99.
99 meter. Clear? Now I am going to substitute all this information. We know what is x1. We got what is x2. We know what is our time 1 and time 2. Am I right?
Yes.
Yes.
Now we are going to substitute everything in this formula. So average velocity, which is equal to x2 minus x1 over t2 minus t1. My x2 will 99 meter. My x1 is 56 meter over 3 minus 2. The total answer will be
43.
Understand?
43.
Yeah.
Yes.
So
Simple.
this will be the answer for the second question. Understand?
Yeah.
Yes.
Yes, teacher.
So brother, I am going to leave the remaining 3 questions for Wednesday class.
Okay.
Do you have any doubts?
Okay.
If you have any doubts, we can share now. Do you have doubt?
No, thank you.
Wait a minute. I can see how many students you are sitting here. How many students are
30.
30 students?
29.
Oh, mashallah, 30 is here. Oh, 18 messages I received. What is this? 90. Oh, you are giving the answer by typing. Very good. Some 4 numbers are here.
Yes, it's for the group for WhatsApp.
For the group. Okay. Okay, brother. It's my kind information again. Please, this week lab is converted to online. Please, when you come for the lab classes, if you are in my section, okay? How many of you in my section?
I don't know, maybe 3 or 4.
No, I have 30 students. Okay, whatever it may be. Brother, listen carefully. If you are in my section, what I am going to teach in your lab, please bring a graph sheet. Understand?
What?
Graph sheet.
What is this?
What do you mean this graph sheet?
Brother, I told you.
Graph sheet. Yeah.
I